The physics concepts behind concussions can be separated into three main categories: kinematics, dynamics, and momentum. Kinematics. Kinematics can be applied to figure out the forces needed for the brain to jolt and impact the inside of the skull. A sudden deceleration that immediately follows the acceleration causes a strong impact force. The kinematic equation that shows this concept is A equals Vf squared minus Vi squared over 2dg. A represents the acceleration, Vi is the initial velocity prior to the beginning of deceleration, d is the distance traveled, g is the acceleration due to the velocity, and Vf squared can be assumed to be 0 since the subject is being brought to a halt. Dynamics. Newton's three laws. Because of Newton's first law, due to inertia, your brain will stay at rest until acted upon by an unbalanced force. The brain is suspended in the skull in cerebrospinal fluid and has the ability to move if acted upon by a strong force. Because of Newton's second law, after the skull receives an impact force, the force exerted on the brain can be represented by F equals ma. F represents the net force, m is the mass, and a is the acceleration. This means that the brain will accelerate in the direction of the net force applied to the skull. Newton's third law states that for every action, there must be an equal and opposite reaction force. The force exerted on the skull by the brain has an equal and opposite reaction force on the brain by the skull. Momentum. Momentum is dependent on the mass of the object and the velocity it is traveling at. This is represented by P equals mv. P is the momentum, m is the mass, and v is the velocity. The brain experiences momentum as it comes in contact with the skull. The faster the brain is moving and the more massive it is, the greater the momentum and the greater the impact force.
The brain is an organ of soft nervous tissue contained in a skull of vertebrates, functioning as the coordinating center for sensation, intellect, ability, and nervous system activity. It is surrounded by fluid and protective membranes called meninges. Concussions are an immediate but reversible traumatic paralysis of the nervous function of the brain. There are different types of impacts for the brain. There is focal impact, where the brain injury is located or where the brain was hit. Point of contact. Linear or translational, where the brain injury, when there is no direct impact to the head, the brain sits inside the skull, unattached, and can slide back and forth. With enough force or whiplash, the brain can be injured on both the coup side and the counter coup. The short-term effects of a concussion on the brain vary from person to person. However, the most likely physical symptoms are headaches, vertigo, ringing in the ears, change in sleep patterns, blurred vision, nausea, difficulty with mobility or coordination, and loss of consciousness. The cognitive side effects are partial and total memory loss, loss of concentration, slow reaction time, and difficulty communicating.
The long-term effects of a concussion on the body and brain. No matter how small of a concussion a person receives, a series of long-term effects on the person's health and body can occur, resulting in bruising, tearing, and possible minor swelling of the neurotissue that can result in a series of different issues. Rest is crucial for your brain and body to recover, which includes avoiding television, computer, speaking loudly or doing fast movements, and getting lots of sleep. Concussions are cumulative, and the recovery from a traumatic brain injury can be extensive. Post-concussion syndrome is something that affects the entire body, causing physical, cognitive, and emotional problems. Second impact syndrome is a condition in which a second concussion occurs before a first concussion has properly healed. This causes rapid and severe brain swelling and often carries catastrophic results. Long-term symptoms can linger from a few months to even many years. This includes long-term memory loss, emotional distress, slowing of some types of movements, depression, which also leads to an increased attempts of suicide by those who have suffered concussions in the past. Further tests reveal that the older athletes who have suffered from concussions experience a thinning of the cortex in the same part of the brain that Alzheimer's affects. Also, those who experienced head trauma had symptoms similar to those of early Parkinson's disease. In the end, biology relates to the study of concussions as it is the investigation of organisms through how they receive factors that disrupt their normal state, how they react to certain aspects, and their ability to cope.